Hey, it's me, Destin. Welcome to the second channel. This is the extended cut of the TNC stamping, metal stamping video as a part of the Smarter Everyday Manufacturing series here. So on this video, you'll see more footage than you did on the main channel video, and it's really cool. I hope you enjoy it. Okay, so this is Weston, and I'm Destin, and we're kin somehow. Do you know how we're kin?
I don't. I've just
I don't either. Our aunts or moms tell us we're kin all the time, and we have no idea. But you have a really cool sheet metal manufacturing facility, and I wanted to make a video about it because I love it. So my buddy John's with us today. John and I are going to work with TNC Stamping to do a thing. We'll talk about that in the future. But yeah, so let's go check out your plant.
Okay.
Is it called a plant?
We call it a plant. We've got 100,000 square feet here in Athens.
You actually manufacture things here.
We actually manufacture metal stampings. So we do some what we call sub-assemblies as well. But yeah, we do all that right here as well as build the tooling. And that's kind of what sets us apart is a lot of metal stamping plants don't build their own tooling. So that's, we do all of that here. So we'll start in the tool shop. We'll get to look at some dies up close and you kind of get an idea of what a stamping die actually is. And then we'll go out into the factory and you can see them in action. This is the tool shop. We have about 15 full-time tool and die machinists and operators here. So,
surface grinder.
Yep, so you'll see all of the standard machine tool kind of stuff in here, grinders, lathes, wire EDM. We have one CNC machine here. But
do you have an example of what you make? So
yeah.
People can kind of, because I think people maybe don't know what's going on here. Okay, that's awesome.
So this is a metal stamping. Metal stamping is the short.
It's called a stamping?
Metal stamping. So it's anything that can be stamped out of a coil of sheet metal. So this particular part is a heat shield for a V-twin motor. So a Briggs & Stratton V-twin lawnmower engine, snowblower engine, generator engine. This is a heat shield that goes on that. This goes to their assembly plant down in Auburn, Alabama.
Can I see that?
Yeah.
And so you will make a machine that makes this.
Correct. Yeah, so what you're looking at here is actually called a stamping die. So this is the bottom half of the stamping die, and this is the top half of the stamping die.
That's crazy.
And we receive raw material in coil form, and it's our job to take raw material in coiled steel form, run it through a stamping die to where we have a finished product that comes off the end of the die.
So if I understand correctly, just flat metal will come in one side.
Correct.
And that will come out the other.
Correct.
Really?
Yep.
And you make this here.
We make everything you see here, with the exception of something like pins and bushings. There are some purchased components, but all of the die steels, everything you see here started as raw steel. We machine it into what you see here. So
is it okay if I touch it?
You can touch anything you want to. Yeah.
All right. So this is one tool. Correct. And so, okay, can you show me how it works?
So this is the top half of the die here. So what you're looking at is the top half of the die. This is the bottom half.
Okay.
So in operation, you have the top half that mates with the bottom half. This goes into a press, and the press moves up and down, and the
like ka-chunk, ka-chunk, ka-chunk.
yeah, whatever sound effect you want to use.
Yeah.
So, and as the material moves through the die, it's attached to the strip the entire time. All of these features are being put in the part during the process, and you have a finished part that falls off the end.
There's an undercut there.
Correct.
Like,
so what this is a spark. The application of this, there's a spark plug wire that goes into this slot.
oh, so it can't cut the wire.
You have to have a feature there that guards against any kind of wire that would cut the insulation or anything like that. So
okay. So I can see. I'm seeing something here. So I see a guide here and here.
Yes.
So that feels like the metal will come straight in here.
Correct.
And
so
then
the material comes from this end and moves, and the material is one piece as it moves through the die until it's cut off at the end. That's what's called a progressive stamping die, because it progressively forms and punches the part until you have a finished part that falls off the end. If the part were to ever be detached from the strip and then continually formed, it would be called a transfer die.
A transfer die.
Transfer die, because you're transferring a loose part from one station to another. But this
So
actually
progressive keeps it attached. Transfer moves a cut piece.
Yep, and we don't do any transfer work here. We just strictly do progressive dies. So
okay.
Maybe better to look at the top half of the.
Oh wow!
But this is the top half of the die. So
okay,
imagine
this is serious. Yeah.
So imagine this is upside down right now, but this would be the last station of the die. It's formed, and then it's actually cut off from the strip, falls in a basket, and you have a finished part.
Okay.
So just to give you an idea of.
So that right there. So this is the top half of the die.
Correct.
Which means there's a mate over here. Is that it right there?
That's correct. Yep. So
can
everything.
Can you grab that part?
Yep.
And it goes like that.
So everything has to line up perfectly.
And so you have to design this whole thing in stages. So it's like a story. Like you start with flat and you.
Correct. Yeah. So Joey Russell, who you met, he does the design work. So yeah, it's you basically start with a flat blank, and you have to figure out how to get these features into the part, and basically have a finished part fall off the end.
Okay, so this is wizardry. I got it. This is why I wanted to come here. I saw a tool like this, and it blew my mind, and I wanted to see. Did I do that right?
Yep.
Okay.
So it would start in the flat state, and as it moves through the die. So this is actually the punch. You can look down in there and see the punch.
Okay, it's hard to see, but it's in there.
So that's the punch that actually punches this hole.
Uh-huh.
And then you have a form that coins it. So you have the coining there.
Yep.
And I mean, those are just two examples of one feature on this part, but imagine every feature on this part.
I'm gonna get my phone out so I can see when you said it. So that's the punch.
Yep.
Okay. Got it.
So, and then this is the coining operation. So you can imagine every feature on this part has to be completed in this tool here.
That's awesome.
And then when it comes to the last station,
okay,
it's formed and then cut off.
They're grinding over here right now, right?
Yep, yep. So they're just doing some.
What's up, man?
They're just grinding on some die steel. So this is Brandon.
How's it going, man?
Oh.
Hey, I'm Destin. What's up, man?
I'm doing all right. How are you?
You running a surface grinder? Yeah.
Brandon was a press operator for a couple of years, and now he's an apprentice here in the tool shop doing the apprenticeship program.
So you're learning how to do all this?
Yes, sir.
Are you learning how to make the machines and stuff?
Yes, sir.
Is it awesome?
It is.
So you're Brandon, right?
Yes, sir.
Is this a surface grinder?
Yes, sir.
All right, so how does this, what are you doing?
I am getting the sides parallel. I've already ground the thickness. I'm getting it parallel now to be ready to go to the mill to be able to put our hose, tapped hose, counterbore hose, whatever needs to be put in it. Then it'll be ready for heat treat. Then it'll be ready for either the wire machine or the CNC machine.
How did you learn how to do this?
Just learn.
Yeah, just sitting here
learn.
working?
Yep.
Yeah.
Yep.
So this is it actually taking material off right now?
Not right now, but I can make it.
Are you about to
Yeah.
anyway? Yeah. Go for it. So how do you take into account the wear of the stone?
A lot of times you can tell, you can actually see it. You can tell by the coloration of the stone because all your work's being done on the edges, that you can see the discoloration sometimes of the stone. You can tell how much you're actually grinding at a time.
And now, are you going down in this dimension and left and right at the same time?
I have fed down, now I'm just setting it feet across.
That's awesome. How much do you have to take off of this?
Right now, it was only about 1,000th out of squares, so I fed down 2 thousandths. I should clean up everything.
That's awesome. And then how do you check that? Like
Just once it cleans up, it's no real set dimension on this one because it's going to be a wire block.
got it.
You just want it to be cleaned up so you got clean edges to pick up your start point of when you go to put your holes in it.
That's awesome. It's complicated stuff, isn't it?
It is.
Brandon, right?
Yes, sir.
Yeah, nice to meet you, dude.
Thank you.
Yeah, and you're the apprentice, right?
Yes.
Cool. How long do you just go to apprentice, journeyman, and then
Yes.
skill trade?
I have right at 3 more years.
And then you'll be a journeyman?
Yes.
That's awesome. Congratulations.
Thank you.
That's a huge deal, man.
It is.
I think that's worth more than a lot of times that's worth more than the college education is having skill
it is.
trade, isn't it?
It is.
That's awesome. Pleasure to
Right.
meet you, Brandon.
So just to kind of go back to the die really quick, everything you see in the die started as a piece of raw steel and has to be machined into what you see here. So the tooling engineer will generate drawings, and then it's up to the tool makers to figure out how to machine this stuff out of just raw steel. So
This is raw brute force brain power and
That's right.
manufacturing. Isn't
Yep.
it?
So this is a little better example. This is the exact same manufacturing process. This is a stamping die. This is the bottom half of the die. This is the top half of the die. But here we actually have a strip.
Oh wow.
This is the actual finished part.
That's the finished part?
Yeah, this is an automotive bracket.
Okay. All right, so this is Mark. Mark is going to explain this die to us, right?
Right.
A progressive die?
Yes.
Okay, cool. How's it work?
Yeah, we feed the raw material in from this end, and like you see, it'd be solid without any interruptions. And we'll pierce 2 holes. These 2 holes are pierced here for the pilots to engage.
Okay.
Now, once the pilots engage the
So a
strip,
pilot is a way to index the parts.
correct,
Is that right?
and that maintains our progression, our feed for each part in each position. You can see we've got the die loaded pretty well with pilots.
So that's the first step.
Yes.
Punch the holes, and then you cut this tab right here.
Right, it'd be cut right there.
So then we cut the tab. Okay? And then after you cut the tab, then what?
Progresses one more distance from the pilots. Get a pierce here. Then as it carries it through, we bring it down to the forms. Kicks these 2 forms up that way.
Uh-huh.
Bring it on down a little further, and then it forms them down again.
So you've got, in some places you have radiuses, in some places you have sharps. Is this hardened steel right here? I noticed that's an insert.
Yes, that's where it forms, and that's all hardened. And the opposing side would be hardened also.
So if you're cutting, you have hardened, okay, forgive me, Mark, I don't know where the cuts are taking place here. This is complicated. Are these side actions?
Yes, these are actuated with drive blocks here that they come in and they trim the bottom side of the
So that's a
edge of the
shear
part.
underneath there.
Yes,
All right, so this looks sharp.
and that's the final cutoff where the final part would fall off.
Okay, so this goes like that.
Yeah. Yeah. It feeds in this direction.
And so you actually put letters in it too.
Yeah. The stamp's in the top side, and it just,
You ground it off.
well, it's just, that's where it's worn
I see.
from hitting it.
So this is the stamp over here.
Correct.
And you can change that.
Yeah, for the date or
Automotive
particular
customers
part.
require date codes and
Really?
part numbers to be shown in the part.
Wow. Okay, so stamped letters comes along, cuts the tabs here. That's a cutter.
Correct. Yeah.
That's a punch.
yes. This is the pilot holes.
Uh-huh.
Then this is the opening for that blank. Where it,
And it just falls out of the part.
right.
So this is the bottom.
Yes.
Okay. And then,
And as we get to this area, that's where that kicks this down on a 45.
okay.
And it progresses down 2 more stations, and it kicks that leg up, so that where this was 45 is now up at 90 degrees to the bend.
Yep. Why do you do a 45 instead of just doing the whole bend at one time?
Different situations by different engineers, they feel differently about having it, but once you have this form right here, you'll never have to touch it again. You're just bringing this angle up to 90.
Yep.
So this is already at 90 to that when it leaves this area.
Yep.
So we're just actually just kicking this one angle on up to 90.
Yep. That makes sense. You said these are side actions.
Yes.
So if you push right, can I push?
Sure, but it's
not gonna move?
Well, a little bit. Get a little motion.
So if you push, how do you get, is there a swing arm in there?
This is the pad that actually strikes the backside of that block and does the pushing.
But how do you take a vertical motion here and turn it into a left and right motion?
There's a 45-degree angle on this slide right here, 45-degree angle on this driver, and once it meets it, it just pushes.
And there's a spring
it on.
return.
Yes.
Okay, got it. This is ridiculous. Weston, this is crazy.
It's pretty wild, yeah.
Okay. And then how many of these can you make in a day? Like thousands?
Yeah. It's got 54,000 parts on it. Now, it's gotten a little bit of a dull edge on one area, and so we're going to sharpen the cutoff
That's amazing.
to bring that back up to a good surface.
So you're reworking this progressive die right now?
Yeah.
That's amazing. That's awesome.
I'll just remove, you can see this is inserted.
Uh-huh.
So I'll take these 3 screws out, pull that insert out, put it on the grinder and resurface it.
And then that knocks all the dull edges off.
Right.
So we talked a little bit about, you know, if you were to buy this tool overseas, we'll call it just bargain tooling.
Let's just say it. If you were to buy this in China, right?
Yep.
When people
Yeah.
want things manufactured,
right.
they go to China.
Let's, you know, a lot of this would be, you know, this block of steel, for example, is likely to be one piece of steel. We make it modular, so die steels can be taken, inserts, die steels can be taken out and sharpened as needed. Because if this were one die steel, if this were one piece of steel, maintenance would be virtually impossible. It would be a lot of work.
So basically, some of the stuff you get, like if you were to buy a sheet metal tool, they would just make this in one monolithic block. Is that what you're saying?
For the most part.
Say this area right here would be one block.
Okay.
And then you'd have so many grinds that you could make on that, and then you'd have to throw it away and replace the whole area. Now this die here is probably, it was built in the 70s.
That was built in the 70s.
Yeah, late 70s, I'd say. And all of the areas that are sharpened a lot are inserted just like this would be, so that you can keep the tool running for years and years.
So this die will get 500, 600,000 hits a year.
600,000 hits a year.
On a heavy year, usually closer to 500,000 hits a year. So you do, you know, if you do the math, this die's been in operation since the 70s.
Thank you very much.
What's that?
Sweet.
Okay, so we've got 3 wire EDM machines, and what a wire EDM machine does is basically wire profiles in die steels with an electrically charged wire that a lot of times can't be done manually or would take days to do manually. So hopefully I got an example of one of those. What's up, boys? Can you hand me one of those blocks over there? Or there we go. So this would just be a die insert here, and you can imagine if you had to machine that, there's very few ways you can actually do that in a machining operation.
Yeah, that's a long tapered part.
Yep. So you're talking about a tapered grinding wheel or some kind of end mill that has that profile on it, and it has to be that specific profile. So what a wire EDM machine does is Boyce would actually
so you got a whole jig in here.
Yep.
He's just making one little section here.
Yeah,
Can't
but
really
you can actually
it.
see the brass wire being fed down through there.
Yep.
But that brass wire is electrically charged and actually burns through the steel. So Boyce would program the wire EDM machine to...
Programming, boys?
Right there.
Can I throw this mic on you for just a second?
Wait.
On you. You okay with it?
Yes.
You're good. I'll just stick it right there. What are you making?
Some inserts. Fixing to run this profile inside that insert right there.
So that's a cutter?
That's showing where it's cutting.
Is this carbide or tool steel?
It's just hard steel. Just hard tool steel.
Got it. How long will it take to run that on the EDM?
45 minutes.
Really?
Yeah.
That ain't bad.
Yeah.
So you guys mostly use SolidWorks, it looks like?
Yes.
What's your background, boys?
I've been here 45 years.
Yeah?
I've been in tool and die 45 years.
Tool and die?
Mm-hmm.
Yeah.
Machine, tool and die.
You think they're going to teach you how to do something for
Nope.
it?
Too late on that.
Are you mostly an EDM guy now?
I am now. Yeah, I took over a man that was in here I started out in 1983 working in EDM and went to machinist and doing tool and die work. He retired a year or so ago, and I volunteered to come back in here before I retire.
So you do wire EDM. Do you also do solid probe or electrodes?
No.
No.
I don't.
What's this machine behind you? Is it wire as well?
It's just an older EDM machine.
What's your favorite machine to use? A new one?
That one right now, usually that one most of the time. Or I've got both of them running right now. I use them both. They're the same, just a little different size.
You running Mastercam to run them?
Mm-hmm.
Yeah. That's amazing. See what I'm doing?
So you can just see some of the other dies the guys are working on. This is just general workspace. All the tool makers have their own toolbox, and they work on dies as they come in. And
Dude, this is the strength of American manufacturing right here. This is a big deal.
a lot of these guys that you've talked to already, Roger started work for my granddad in his 20s.
Really?
Boyce has been here since the 90s. Mark has been here for a while. So a lot of these guys have been here for a really long time, and we're fortunate for that.
Do a lot of people do this in America?
Not anymore. You know, when these guys came up in the trade in the 60s and 70s, it was a really popular career choice, but not so much anymore. It's, you know, you think of a factory, dirty, dingy, and there's all these stereotypes, but you know, the reality is you can be creative. You know, factories are a lot safer than they used to be. They're a lot cleaner than they used to be. So hopefully people are considering it as a viable career option. But there's this gap between the 60s and 70s until now, and so we have this workforce, tool and die workforce, that's getting close to retirement, and we have some young apprentices that are coming through, but we have this big gap that we're trying to fill. So
pretend I'm an idiot, which isn't hard, right? Tell me, when I hear tool and die or tool and gauge, can you point to something that shows me what that is? What is a tool?
A tool?
Yes.
All of this is tooling.
Explain it to me.
Every piece of that's tooling. That's a die steel.
Okay.
And it says
So this is tooling.
right. This is tooling.
Now what's gauge
The gauge,
or die? What is die?
the die is a complete assembly.
Show me a die.
This is an assembly. This is a die.
This is a die. So the tooling goes inside
Right.
the die.
Right.
Okay. And so when somebody says I'm a skilled tradesman or a skilled tradeswoman, whatever
Right.
they say these days, so do you basically that is the knowledge required to build a die like this?
Correct.
To make a product.
Correct.
Okay.
Okay. Now, then there's mold, which is an entirely different thing. You know, it's injection mold, plastic.
Plastic
Yeah.
I've been working on injection molding. I'm
Right.
trying to learn that.
You got plastic. You've got die cast, which could be aluminum. It could be magnesium. That's a different genre too. You know, it's completely different skill sets for each one of them.
So what's hard about this skill set? And understand my ignorance when I ask that question. My dad was in tool and gauge.
Right.
I know it's a lot of precision.
Right.
Is it patience? What do you need to do?
It's about the fit. You know, drilling holes is drilling holes, but when you put it together, everything's got to go together the way it's supposed to go together. Good example, this tool here.
Show me.
tool's been around for a long time. For some reason, it decided just didn't want to go in there no more.
This
Yes,
round.
that's your pierce punch. It wouldn't go inside here no more.
Okay.
It's out of place. It's called being out of alignment.
Okay.
What causes that? Who knows? It could have been a die crash. Could have been a bunch of things. At that point, somebody's got to figure out how to get that back where it's supposed to be. Sometimes it's a matter of a light peck on that, and sometimes it's a complete remount. You know, and you're talking of thousands.
So you're more like watchmakers. So tool and gauge. I mean, you ain't watchmakers, but you're more like a precision.
It's two different things. You can either be a sledgehammer or a surgeon.
Okay.
You know, it just depends on what you're doing. Sometimes, like I say, you might hit it like a hammer. Other times you might change the squareness a few tenths just to affect where that punch goes.
2/10, like meaning a tenth of a tenth,
Yeah.
a tenth of a thousandth of an inch.
Right.
Okay.
Matter of fact, that was off. I think that punch was out of square about a thousandth for some reason, and who knows how it gets like that, wear, tear, whatever. You know, anything can get something off. But sometimes, if you think about that being out of square at the back side, a couple of tenths, and the amount of tilt, you being an engineer, you know what kind of tilt that does to something. The longer it gets, the farther away it gets.
Yes.
So it doesn't take a lot.
Got it. And so you got to figure that out. So the
Yeah.
engineer draws it. Will a good engineer spend time in the shop?
They should.
Okay.
I'm not saying they will. I've seen some that didn't, but
They got clean fingernails?
yeah.
I ain't got no fingernails. I don't know what the heck's going on, but I'm talking more country around Roger. I can feel it.
It may be in the air.
It's rubbing off on me, man. Okay, great.
If you want to see a gauge, I'll
Yeah,
show
me a
you
gauge.
what I actually gauge.
Yes.
The reason I don't talk on camera, too country.
Too country? Oh, the thing me and John are working on is over there. I ain't gonna show you that yet. They look pretty good, don't they? Okay, cool. That's awesome. Okay, so a gauge is a thing to check a part that you've made
Right.
to make sure it works.
Right. It's a twofold deal. It's not just gauge. They actually do a setup sheet on each part, and there's certain features and dimensions that are checked on, whether it be comparator, a depth mic, whatever they got to use.
Like an optical comparator or
Right.
a depth micrometer.
Right, right.
I'm just interpreting
Right.
here, yeah. You speak the language. So in all seriousness, that alone probably takes years is to learn the vocabulary of the trade, right?
You hear that? It takes years to learn to speak like I speak.
Oh,
All right,
man.
now watch me put it on wrong. Okay. It's an what they call it, attribute gauge.
A what?
Attribute gauge.
Attribute gauge.
Right.
Okay.
And basically, this is at the press
So as it's running.
as it's running. And like I say, I'm not trained in this gauge.
Okay.
But anyway, typically these gauges are clamped one or more places. This one just happened to be two. Anyway, that comes down, that locks that in, and basically that's for checking. And all this is color coded. So you got a red gauge.
So red means no go.
No.
Green means go.
Red is actually the gauge you're using. See that?
Yes.
Red and red tells me I need to check there.
Okay.
Green is go, red is no go here. But that color coding there is to tell you what attributes you're checking with that gauge.
Okay, so a gauge is a way for an operator who's making a machine work.
Right.
It's a way for them to measure the quality of their process as they're doing.
Right.
That's what gauge is.
Right.
So you've got this gauge right here.
Right.
This is a go and a no-go gauge.
Correct.
So the no-go is bigger and the go is smaller. And you're
Right.
gonna make sure, you're gonna check this attribute right here.
Correct.
All right, let's go for it. So you're picking that thing up, you're gonna bring it right in here. So is this the go or the no-go?
That's a go.
The go should be able to go, and it does.
Just freely go.
And then the no-go cannot fit.
Can't go at all.
So that's a huge tolerance on that particular part.
That's a huge tolerance.
Okay. But the same thing works like within thousandths of an inch.
Right.
And so then you could say this particular part passed inspection,
Right.
and you can sell it to the customer.
Right.
Okay. Do you have to check every single part?
No.
How many do you check?
I would say hourly?
Yeah, they check 3 to 5 every hour when they're running the parts. So we do have a quality lab, and we can do a full quality inspection of the part with optical parameters, CMM. But this is so the operator can check parts basically on the fly and make sure there's no major problems while they're in production. But we do have a quality lab that does pretty intensive quality checks.
All right, so the tool and gauge and the tool and die people are the backbone of the manufacturing process.
Absolutely.
Okay,
Yes.
and now operators use tools that you guys create.
Yes. But,
Okay.
and the operators, you know, they're actually skilled. A lot of them are very skilled. The die setters and operators, just loading a die wrong can cost a lot of money if they do something they shouldn't do. So their skills are up there too.
These people know what they're
They
doing.
know what they're doing.
Okay, that's awesome. Great.
Yep.
Thank you very much.
You're welcome.
So just
Edit you out?
Yeah.
I'll edit your accent in.
Keep me out of frame.
so the dies that we looked at, this is what they start out as. So this is just raw steel. This is the stuff that gets machined into punches and forms and any kind of die steel you can imagine. This is what it starts out looking like.
Okay. Is this tool steel?
Most of it is either A2 steel. There's some cold roll. There's some D2 and some cold roll in there, but most of it's tool steel A2.
Can we look at your bridge ports real quick?
Sure.
Yeah. Cool. Yeah. Yes, sir.
Qualify something. These kind of gauges here are specialized.
1 second.
Oh, we're back on. We're rolling again.
Say it again.
I said these gauges are specialized. They're built by people that's what they do. That's their genre.
Those gauges?
Yes.
Okay.
They're based on how the model. They take a model and build a gauge to the model.
So you guys bought that gauge?
Yes, they're built by gauge builders.
Okay.
Okay, we build some gauges, but not to that level.
Okay. Sounds good. So what if I understand what just happened? You realized I was learning the vocabulary and you were afraid I was going to give you credit for that gauge. Is that right?
Yeah.
Okay. Yeah. No, I understand because you have pride in your work.
Yeah. Well,
And you know they have pride in their work.
we build some gauges too, but you know they're very specialized. We can't compete with other folks. You know that's what they do every day. You know our cost would be way above what they cost to get those built because that's what they do every day.
Okay.
Just
Yeah.
like die building, we don't build injection molds. We build dies,
Yeah.
stamping dies.
Thanks, Roger. Yeah. That's good. No, I want to qualify that. You get candy. All right, so I asked Weston if I could see this. How's it going? I asked Weston if I could see this, all your bridge ports. That's the strength of American manufacturing.
Yep. When you think of tool and die, a lot of people, the first thing they think of is a bridge port. So this is basically a manual machining center. It's you're essentially looking at the same machine right here, but this the CNC is automated, so you program the machine on a computer, and with a bridge port you do it manually with cranks and handles.
And you guys, all these run?
All of them run, yep.
That's awesome. These haven't been set up in a while. That's good.
But we still use these quite a bit. You know, it takes quite a bit of time to program a CNC, and you know, if we just need to crank out a die steel pretty quick, we'll get one of our machinists to throw a piece of steel on there and machine it out. Cody, our CNC programmer, stays pretty busy too. So,
Really?
Yep. So.
You Cody? Yeah. Hey, I'm Destin, man. What's up? So you're the CNC operator?
Yeah.
Is it what are you working on now?
Just some prototype stuff.
Really?
Yeah.
So is it like development?
Yeah.
You're trying to figure out the good stuff. What do you run? You run Mastercam? Or
Yeah, Mastercam.
Do you do G-code by hand ever?
If I have to edit, I'll do. I normally will edit by hand instead of having to come back over here to do it. But
Man, you got a gamer chair here at TNC Stamping. What's up, man? So you doing some Twitch streaming on the side? Does it get slow? You start Twitch streaming?
you got to be pretty comfortable to sit here for a couple hours.
Do you really?
Staring at this computer, you know.
Yeah.
So.
Is it a? How often do you kill a part?
I've killed 3 in 3 years. I don't do it often. They let me take my time and kind of do it pretty thorough. So I'm pretty careful.
How have you learned? Did you go to school for it?
I did, yeah, and I self-taught a lot of it. Didn't have a lot of opportunities to learn it in previous places of employment, so I actually bought Mastercam for my home use and just learned it at home when I would get off work at night.
Really?
And kind of taught myself how to do it, and I went to school for machining and taught myself how to program.
Where'd you go to school?
Northwest Shoals.
Northwest Shoals? That's awesome, dude.
Yeah.
So you decided you wanted a skill to be marketable, and you went and bought it at home to invest in yourself.
Yeah, they didn't want to train me to do it where I was working. I was the night shift supervisor, and they didn't want me to change roles. So I just invested in myself and got it for my home use and learned it and found somebody to hire me to do it, and then it was game on from there.
Dude, that's awesome. Congratulations.
Thank you,
what was
buddy.
your name again?
Cody Martin.
Cody.
Yeah.
That's the way to do it, man.
Yeah.
Has it paid off?
Oh, for sure. Yeah. Yeah, I love it. Yeah.
That's cool.
I sure do, buddy.
Thanks, buddy. I'm gonna steal this.
All right.
Thank you very much.
But he's writing a program for essentially everything that he puts into that CNC. This is not a production CNC where he just pushes a button. He writes a program for everything that goes in there. So
Got it.
there's not a lot of people that can do that.
How on earth, I'm trying to learn CNC right now, how on earth did you learn the speeds and feeds?
By ear listening.
Really?
If it sounds like crap, it's probably not right. And it's just literally constantly adjusting. And there's formulas out there, and that's a good starting point.
SFM formula?
Yeah, that's a good starting point, and then go from there and just start adjusting while it's running on the machine and what sounds good and what's coming off as a good chip and not burnt. And when it sounds like butter, you're cooking with gas.
That's awesome, dude.
Yeah.
Nice to meet you, Cody.
How you too, bud?
Yeah. You okay with everything so far?
So far, so what we're moving into now, the blender blade area, don't want to get real close up to those presses, just kind of, maybe from here to the window or so is about as close as we want to get to those.
For safety reasons or proprietary reasons?
Proprietary reasons.
Okay,
so,
sure.
Yeah.
All right, so these guys have figured out the blender blade production system, right?
Yeah, that's right. I need to give this back to Ralph.
Go for it.
This is the blender blade manufacturing cell. So one of our largest customers is a kitchen appliance manufacturer, and we stamp every blender blade that goes in their blenders. Every blender blade you see in this particular brand of blender is made right here in Athens, Alabama.
Athens, Alabama, the blender blade capital of this company that we're not going to talk about.
So last year we stamped between 35 and 40 million blender blades.
That's amazing.
It's a lot of blenders. But how are you doing? They're stamped right here in this cell. It's food grade steel, food grade stainless steel. They're washed and they're packaged, and they go straight to the assembly center in Mexico from this cell right here.
Can we see stuff going in?
Yes.
Or is it okay to see what we can? How you doing? I'm Destin. Nice to meet you, Tabitha. How you doing? So she makes it happen,
She makes it happen, yeah. So this is the actual part we're looking at here.
So you make millions of those a year?
Yep.
Huh? Yeah, so you run all these presses?
Yes, sir.
And do you ever cut yourself on the blades?
I'm really extra careful.
You're extra careful?
Sometimes I might nick myself, but as far as cutting myself, I'm very careful.
This is probably the worst audio environment to record anything, but can you show me a basket?
This right here is one of my baskets.
So these are the blender blades. Are these done?
These are ready to be put in the wash.
They're going to be washed.
Wash. Right here.
That's what you're doing over there.
I'm washing. I'm rinsing. Then I'm drying.
Wow, you're doing it all right here.
All of it right here.
So that gets the oil off of it?
Yes, sir. Get the oil off of it, then it dries it, and then it comes up down, and I package it, put it on the pallet, and be shipped.
Do you do it by weight? How do you know how many are in here?
I have it set on the counter on the machine.
Got it.
This basket is 2,000.
And Weston, I can imagine you don't want people to see that, right?
Yeah.
Yeah. So don't look at that. Can I blur it? Okay, cool. We'll blur that. Tabitha, it's a pleasure to meet you.
Pleasure to meet you too.
Yeah, I'm gonna steal that from you.
Okay.
Thank you so much. There's things about that process we can't show, so we probably blurred some stuff out. Yeah. Yeah.
But this is the so this is the oldest part of the plant. This green press. This is a 160-ton press here.
I can hear it like a dragon.
Yeah, it's back there.
You've seen that part before, haven't you? It sounds like a dragon.
But this is actually the first press that we bought. So
This one right here?
This was the first press that ran stampings for TNC.
Do you still use it?
We still use it. Yeah, almost every day. So
This one right here?
yep, it's a Stamp Tech 160 ton. So usually you can see the tonnage. It's labeled on the press. So this one is a 160 ton. The biggest press we have is a 330 ton. You know, stamping equipment hasn't really evolved a lot over the past half century. Servo presses, which we'll see in the other building, that's really the biggest and latest and greatest technology in stamping. But for the most part, stamping presses have been the same for the last 50 years, and this is a good example of that. So
It still works. It was a good investment.
Yep.
Yeah.
That was probably a, I don't know, that was probably a $10,000–$15,000 press back in the 80s, and it's
Probably makes that per week now.
yeah. This is the older part of the plant. When we talked about coiled steel, this is how we receive material. So when we receive raw material, that's what it looks like.
So that's not a die right there that we...
No, so this is, just to take you through the process, so this is a dereeler.
Dereeler.
So you have a reel or a coil of steel. It's loaded onto the dereeler. Then it's fed through a straightener. So coiled steel has a bow in it naturally because of the coil, because it comes in coil form. So it goes through a straightener. Basically, you have rollers on the top and the bottom that apply pressure and straighten the part. Then you have a feeder. So the green part there is the feeder.
It's oiling it, I can see that.
Yep. So that's actually what is pulling the material into the press and through the die. And then you have the press itself. So at first glance, it's a pretty simple part, but you actually have a hem on this side of the part that's completely folded over
That's hard to do, isn't it?
It's really hard to do, and it's being done in a progressive stamping die, so pretty impressive.
So this is all scrap?
This is all scrap. So you'll see these scrap bins beside every press, and this is melted down, turned back into coiled steel, and a lot of it is probably sent right back here. Hey, Donnie.
You can see it happening. So that thing is slamming up and down. How do you keep from hurting yourself on that?
So if you look at every press in here, they have these yellow bars on the sides of the press. So that's actually a light curtain. So you have a laser that reflects off of a mirror and goes into a reception point, and we call it a light curtain.
So if you go inside that, it'll cut off.
That's right. So there's a light curtain on every press in this factory. So I'll use the rags for example, but if you break that light barrier,
so from there, where's it at? So that yellow thing to that red thing,
and then back to the corner.
Yeah.
Stop. So that's how we keep from hands and arms and things like that getting cut off. The stamping used to be notorious for injury, missing limbs and things like that. We've pretty much eliminated all risk of that. So.
That's awesome.
Yeah.
So we got a dereeler, a straightener. Oh, I'm seeing a gauge. And you said that's recycled?
Every bit of scrap you see today is recycled. Yep.
That's amazing. Thank you. tension.
Yeah, you hear the breakthrough.
You hear the break.
So we, just to kind of show you the size range of stampings we do, the stampings we've seen so far are on the larger end of what we do, but we do pretty small stampings too. So this die here is actually stamping 3 parts with 1 stroke, so we call it a 3-out.
3-part with 1 stroke.
Yep. What's up, Chris? Oh yeah, you got a part.
I had to avoid the light curtain.
Yeah. This is a ferrule, right? Yeah. I just need one.
How you doing? I'm Destin.
Chris.
Nice to meet you, Chris.
Chris is the supervisor over this particular building.
Oh, wow.
Yep.
So sometimes you jump in and you're running presses?
Yeah. But this is a ferrule.
Called a ferrule, you said?
A ferrule. Yep. It goes on a shaft that rotates in an appliance application.
It's doing that in 1 stroke or 2?
It's doing this in 1 stroke, and you're getting 3 parts per stroke. So If you look at the strip, is the slinger running? Oh, it's not running. We might come back to the slinger.
Oh man! I just got inside the mind of the designer. You can't, if you're doing 3 parts per stroke, you can't do them all in the same plane because it'll potato chip. So they're staggering it a little bit.
I can't say.
It's at a diagonal.
It's the reason I understood it was at a diagonal is so you can keep the parts segregated when you stroke the parts. So you have a left, right, and center, and they stay segregated.
Oh wow!
When they come off. So for quality purposes, you can tell if the right's off, if the left's off, if the center's off. But
that makes sense.
But you may be right if you stamp all of them.
No, I just made that up. I don't have. This is my first time in a metal stamping factory. Chris knows. Well, I asked Chris a quick question. So, can you tell if the press is messed up by hearing?
Yes, it will make a different sound.
It'll make a different sound?
You'll know that you need to shut it off and check it out.
And you know what's going wrong, or you know to go get the tool and die guy?
If we check it out, then we get tool and die.
Yeah, because those tool and die guys, they don't know everything, do they?
Not everything.
All right, thanks, Chris. What's the loud one that sounds like a dragon stomping?
Okay, that's our 200-ton press in the middle of this particular building. It runs a lot of automotive parts with it. So some tools are louder than others based on the gauge of the steel, the number of moving parts in the die. This is a particularly loud die, but so that's they're not all this loud, but some of them make a lot of racket.
What's it making?
What's that?
What's it making?
It's an automotive bracket. It's a dashboard component.
Okay. There's another gauge.
There's a gauge.
There's a gauge.
It's actually an aluminum bracket, so we do quite a bit of aluminum here too, along with steel.
That thing is loud.
It's loud. This is Tim.
How you doing? Good. So how many parts will this make a day?
It'll do about 24,000 on it.
24,000. Wow. Why is it so loud compared to the other ones?
The press is kind of getting some age.
Okay. But it's still working.
Oh yeah. Yeah, it works great. It's just kind of old.
You always wear hearing protection?
Absolutely.
Yeah. Absolutely.
Absolutely.
That's amazing.
It's a lot louder on Friday when nothing else is running.
Really?
I think it's just the way the press is.
Interesting. Does it always run the same thing, or do you run different parts?
I run different parts. I've got another aluminum part, a 107 and 108. I've got to put in after this one.
How many years have you worked here?
10 years.
You said it's Tim?
10, yeah,
What was your name again?
10.
Tim. Nice to meet you, Tim.
Been here for 10 years.
You like it?
Oh yeah, I love it. I wish I'd have came to work here.
Yeah. Good people.
Absolutely. They
That's
take care of it.
Do they?
Yeah.
That's great. Nice to meet you, Tim. If I understood him correctly, he'll run that press, and then he'll come get another tool, and he'll bang out another,
Correct.
however many parts.
Yep. If it's a really high volume part that's going to run every day, we'll have a press that's dedicated to that part. But for the most part, the presses here run several different dies.
Wow. So why stamping?
Why not? You know, I've been asked that question a lot of times. You know, how did my granddad and his business partner come up with the idea? And my granddad worked in sourcing before he started CNC stamping. He was responsible for purchasing stampings, and he saw a need for it. And he knew John Turner was owned a tool and die shop, and saw the opportunity to do this for a living.
They collaborated, bought the first press, and kept going.
Yep, that's right.
That's
so
awesome.
He passed away in 1997, and my dad and his sister that you met, they run the business now. So
I'm pretty confident your dad worked with my dad.
I think they did. It's
Other than
Yep.
Saginaw.
So so my dad was an engineer at Saginaw. He's a mechanical engineer, and
My dad was in Tool and Gauge.
Okay.
Yeah.
So they probably crossed paths. But my granddad was running TNC, and they didn't have a very robust quality system, so he hired my dad to come develop the quality system here. And that's still #1 priority at TNC today. That quality starts at the top and flows down. So,
That's awesome, dude.
Yeah. Yeah.
What's this?
So this is a heat shield. So the heat shield that we looked at in the tool shop, that goes on one side of a V-twin engine. This heat shield goes on the other side of a V-twin engine. And these go to the Briggs & Stratton factory down in Auburn. So every V-twin, they call it a mid-block V-twin. Every mid-block V-twin they make in Auburn,
That does not translate to audio on the video. That's loud, isn't it? There is something happening when that bangs.
So
yeah, I recognize that.
So this is it's not the same part, but it's similar. So the part we saw would be it's the heat shield for one side of the cylinder, and then this is a heat shield for the other cylinder. So if you think of a V-twin, you've got a heat shield on this side and a heat shield on this side.
Oh, so I see how it's all happening now.
Yep.
Man, that's fast. How you doing? Doing well. Why are you catching them? Making sure it works good?
So a lot of times you'll have a slug. So this is a piece of scrap that's punched out of the part. A lot of times you'll have a piece of scrap, we call it a slug. It'll get hung up in the die and it won't clear the die. It can have some effect on the quality of the part, whether it's aesthetically or have some effect on some kind of dimension. And so what he's doing is looking at the part and just making sure there's no slug marks. It'll go through a pretty rigorous quality check, but he's just making sure there's no slug marks, nothing that looks amiss, so we don't run a few thousand parts and miss anything.
How big? Is this a 275-ton press?
275-ton press.
Wow. that's incredible. That's amazing.
So this is it goes on the same V-twin engine. This is a back plate. So this is a heat shield that goes around the flywheel at the base of the engine casting.
So this is also 275 ton press.
275 ton, and he's going to single stroke it. So what that means is he pushes the palm buttons and the press cycles one time.
So I can see what happens.
Just so you can see what happens. So you'll see the material progressing through the die, and
that's awesome. All right, Chris, you gonna single stroke this one? All right. Can you hit the button when I'm ready? All right, so we're starting with blank steel. Let's punch that hole in it, Chris. All right. Now let's punch another set of holes in it. It indexes. Now what happens? Now it's gonna start forming it, or more holes? Form the outside, okay? Now you're gonna form it. All right, ready? And you're just checking them as they come off. How they look? What was your name, sir? Leroy? Nice to meet you. You do awesome work, man. That's amazing.
Leroy's mom was one of the first employees of TNC.
Really? So how long have you worked here, Leroy? A year? And your mom's worked here for how long? 25. So it's a generational thing. That's awesome, man. And does she run presses too? Yeah. That's great, man. It's nice to meet you. Yeah. Dude, that was the moment where you can see everything and you understand what's happening.
Yeah, it's a hard manufacturing process to describe. I've tried to describe it to people in 5 minutes or less, and you just can't.
You can't. Yeah. It's amazing. All right, so where to now?
So we'll go across the parking lot to the newer side of our facility. We'll look at some servo presses over there, our quality department, and a few more presses.
So what's making these presses hit? Is it a flywheel?
So there's a flywheel. We can see the flywheel. So there's an electric motor that turns a giant cast iron flywheel. Every press we've seen so far, that's what creates the energy. That's what creates the force for the press.
So you take electric energy and make mechanical momentum.
Correct.
Is that the flywheel?
Correct.
So does that mean there's a clutch?
There is a clutch. Yep.
So the clutch engages the flywheel and strokes it down.
Correct. Yep.
Even the big one does that?
Even the big one. So every press we've seen so far, and every press really for the past 50 years has operated just like this. But what we'll see on the other side of the parking lot is called a servo press. And this is a press that uses electric motors to actually drive the press.
To bang it out.
And there's a lot of features of a servo press that this press cannot do, and it's pretty impressive. That's the way this industry is moving.
Do people work those presses all day long, every day?
Yeah, so we work a 4-10 schedule here. We used to have a second and third shift, but right now it's just 4 days a week, 10 hours a day. And so yeah, that's what they do.
That's amazing.
We try to create as relaxed of a work environment as we can for manufacturing. There's nobody breathing down their neck or looking over their shoulder. You know, they're expected to work hard, but there's no benchmarks or anything like that. So
everybody seems like really cool.
Yeah,
they're really relaxed. And
yeah, and that's kind of the environment we try to create. It's, you know, turnover is a big problem in manufacturing, and we've been lucky to hang on to a lot of good people because of that. So
good culture.
Yeah, culture.
Yeah,
absolutely.
Yeah, you can. You know, you can have somebody standing there with a clipboard making sure somebody meets their production rate, but when they work for a month and leave, what good have you done? You know, so yeah.
So in terms of manufacturing in America, human rights is a big part of it.
Yeah.
Like people
you're cool with people, let people like have a life.
That's right. Yeah. I mean, we understand. You know, that at the end of the day, this is a paycheck for people. This isn't. They don't do this for fun, but we want to make it as enjoyable as we can while they're here. You know, it's a manufacturing plant. It's hard work, but there are things you can do, and there are systems you can put in place to make sure people don't feel like they're under too much pressure. So.
Yeah.
This is Todd. This is the guy that makes.
What's up, Todd?
He's our maintenance manager. So.
What's up, Todd? I'm Destin, man. Doing all right?
I'm good.
Good to meet you, man.
Smartest man in the plant, right?
You're the smartest man in the plant. He makes it all work.
Yeah. So this is raw material warehouse. This is where we receive all of our raw material in coil form, like we talked about.
This is just steel, or that looks like aluminum.
That's galvanized steel. We do a lot of galvanized.
That's a lot of metal, man.
It's quite a bit. We process, I think it's 10 million pounds a year, so 5,000 tons. I think that comes out to. But and that's mid-sized stampings. You know, we're not there. There's people out there with 1,000 to 3,000 ton presses, but we're a mid-sized stamper. So, but yeah, we process mostly just cold rolled steel, galvanized, a little bit of stainless, a little bit of aluminum, a little bit of red metal too. So we do copper, bronze, phosphor bronze.
So these are parts ready to ship out.
So these are in process parts. So this particular part, it's a heat shield like we've seen. But it'll have nuts that get inserted into the part, and we'll see that. So we do a lot of manual assembly too.
You'll stake them and stuff.
So yeah, so we'll have PIM. We call them PIM nuts. So they're threaded nuts that get inserted into the part. So these are still work in process parts. So they're staged, ready to go into the assembly area. So most of the red metal stuff we do is electrical contacts.
Can you show me a part?
Yeah, we can. Well, we have some parts out there, but you can see just how thin the material is because most of them are internal electromechanical type parts.
Probably shouldn't touch this because it'll.
Yeah, you actually we require operators to use gloves when they're handling the red metal because it will tarnish. Thanks for taking that into account. But
yeah,
this is. We usually receive most of our material in the morning. So if you come in here at 7 o'clock in the morning, there's forklifts everywhere, material being received in.
So as we walk in here, can you tell me why people should do this in America rather than overseas?
Yeah, there's, I guess the number one reason is that stuff's going to go wrong. So if you're in manufacturing, there's going to be problems. And, you know, if you have an overseas supplier, there's a time difference. Obviously, you can't jump on a plane and be there or get in your car and be there in a few hours. A lot of our customers are regional. Briggs & Stratton is a good example down in Auburn. If we have an issue, or if they have an issue with us, I can be down there in 3.5 hours and we can work it out and we can be running parts that afternoon. So, and with just-in-time delivery, they don't like to keep a lot of, any customer, they don't like to keep a lot of inventory. And when you're shipping cargo containers from overseas, you have to find somewhere to store that stuff. We can run parts, put it on a truck and have it to you the same week. So just-in-time delivery, there's a big push to cut down on excess inventory and have boxes and containers sitting everywhere in your warehouse. So a regional supplier can kind of meet that need. You know, like I said, we can run parts and we can have them to you that same week.
So basically the ability to change the dies or fix any problems, there's the logistics of it, and you said safety was another one.
Yeah, safety is another one. So we run some parts that are safety critical. We run some parts that serve the rail industry, in particular railroad crossing arms. Those parts can't fail. It's just a matter of security. And when you get down to the nitty gritty, the parts that you buy from overseas just don't have the same quality reputation that you buy here in the United States. So parts like that, there are customers that are willing to pay a premium to have them made here in the United States. So
that's awesome.
Yeah.
Are we about to go through that door?
Yeah. So this is this is our quick door. So our raw material warehouse is not climate controlled. This is a way to just contain that cool air during the summer and contain that warm air during the winter. So, rather than a garage door slowly going up and down, we have our quick door, and it kind of helps keep this area climate controlled.
How are you doing?
This is the part we were looking at out there. So so what she's doing is inserting the nuts.
How are you doing? I'm Destin.
I'm
Sharon, nice to meet you.
So
inserting the nuts?
Yeah, so she takes the part with no nuts,
I'm making a video about how they do what they do.
Oh, okay.
How is that working? How many of these do you do a day, Sharon? Wow. 300, that's amazing.
And I look at it, I always look at it, I have to check it, make sure, everything is good. So I'm looking as I'm doing it.
Yeah, you're doing quality control.
Yeah.
I'm gonna not bother you so you don't get hurt. So she's doing quality control as she's going.
Thanks, Sharon.
Thank you. Yeah, nice to meet you as well.
So these are our two servo presses. We bought the one on the left in 2018, and then we bought the one on the right in 2019. These are the newest, latest and greatest stamping presses you can buy. So we looked at the cast iron flywheel that generates the power. So these actually have electric motors that generate the power for the stamping operation.
That's amazing.
Yep. We'll see if they're about to run.
Yeah.
So this is another automotive bracket. So you have the two studs that are actually inserted in the die. So you have two studs that are fed through
As it's going.
as it's going. So
These are the parts.
these are the parts. Yeah.
How is it put in there?
So we have a stud insertion unit that is in the die. And you can go ahead and fire it up. Oh, he's waiting. You see the tubes that come, we'll go around the back side of the die once he starts it, but we have tubes that feed the studs into the die, and then we have a head unit in there that inserts these and actually stakes them into the material while the part is still attached to the strip.
So you'll take two parts and put them together inside the progressive die.
Yep.
That sounds very complicated.
It's pretty complicated.
That feels like a big deal.
It's a pretty big deal, and it's a big cost savings too, because this would typically have to be done in a secondary operation like we just saw with Sharon. So this way you have a finished part that falls off the press, you can put it in a box and ship it to the customer.
That's awesome. Why are there cages around that tool?
So you have loose parts that are being attached to a fixed part, and when you have moving parts and 330 tons of force coming down,
it can shoot out.
It can shoot out. So
Yeah.
it's just a safety precaution. This is one of the few parts we have that there are loose objects being attached to a fixed object, and it's just a safety precaution we have.
Got it.
One of the features of a servo press is that on a traditional mechanical press, the stroke speed is the same throughout the entire press stroke. So if you can look at this press behind us, the stroke speed remains constant through the entire press stroke.
Is that good or bad?
It really hasn't made a difference up to this point, but what you can do with a servo press is you can bring the press down to bottom. You can actually slow the stroke speed to, let's say the material requires a draw. If you have a fast stroke, you could potentially tear that material. So you slow the stroke down, draw the material, and then you can speed the press stroke back up to clear for the material as it moves forward. I know it's a little...
That was hard.
Yeah.
That was hard. I've hung with you this whole time, and then you introduced servo presses, and it blew my mind. Okay, so what? Say it again. So you go down. You can hold it down.
So you can slow the press. You can hold it down, or you can slow the press stroke down to draw the material. So let's say you have to draw.
I see.
You're essentially stretching steel. If you do it quickly, you can tear the material. And so what a servo press can do is when you draw the material, you can speed the stroke back up.
I got it. It's a strain rate.
Yeah.
If you pull it too fast, you exceed the tensile stress. If you do it slow, you can keep it in the plastic regime and you can stretch it.
But after so you can see how it comes down and slows down and then speeds back up.
Oh, there's more finesse to it. So you actually speed the stroke back up to clear for the strip.
I see.
And that's a servo press. Thanks, buddy. Light screens are up there. Can I stand right there? Sure. Right here. We'll stand right here. Yes, sir. And we can go around the back side too if we need to. I like the hollow sound when it punches the metal. Yeah. But the press stroke speed is that's the big deal with the servo presses. You don't have to have a constant press stroke speed. But the tubes are where the the studs are being
So the studs are coming in those pipes and they're being fed in directly. Oh, I can see it. If you look close, you can see where it's going in. So this is feeding the nuts in.
Yep.
Or the bolts.
Yeah, studs.
Studs. It's going in those tubes all the way up, and then it's going in. Yep. It's complicated. Wow. Very thick.
Yep.
Dude, that's serious metal punching.
Yeah. But there are a lot of things we can do with a servo press that we can't do with a traditional mechanical press.
Got it. This is a serious business you guys are operating
Yeah.
here.
Yeah, a lot of people are surprised to know that it's here in Athens.
Yeah.
We ship parts all over the world.
Really?
And we do it right here in Athens. So.
That's amazing. What are you making here?
So this is proprietary.
So we can't show any of this behind you.
You can show it from a distance. I'll get the part and we can look at it.
I'll just blur it out.
Okay. Yeah, so this is an electric motor mount. So what you have is essentially three pieces. So you have the U-shaped mount.
Yeah.
You have the square part here. That's a stamping. That stamping is actually stamped in that small green press behind you.
Okay.
And then you have the bearing. So there's three parts.
So you're making a part that incorporates a bearing, and you're doing it all here.
Correct. Yep. So this part is manufactured in one process.
How long did it take you to develop that process?
When it was all said and done, we had a few years worth of work into it. But
so that's why I can't show any of this.
yeah. There'd be some people that were upset with me that spent several years developing this if I'd put it on or if Destin puts it on YouTube.
Yeah, but once you develop this process, you've established yourself as an indispensable part of the supply chain.
Correct. So our mission is to provide value to the customer. And if we can do that by taking a manual operation and automating it, that's another way to keep jobs here in the United States too. If you sent this part overseas, there's a good chance that those three parts will be assembled by hand. So if we can automate it here, that's a great way to keep jobs in the States. And we have the ability to do that here.
That's awesome. That's great. Wow.
So these are some of the smaller presses we have.
Dude, this is like an army of presses.
Yeah, so this is, TNC used to be full of presses this size. And they're small. A lot of them are fingernail size, electrical contacts and things like that. And a lot of that has gone overseas because you can fit 10,000 parts in a box. It just doesn't make sense to do it here when you could
when you can get it done overseas at half the price, and freight is dirt cheap. So we've unfortunately seen a lot of that go overseas. So we're moving in the direction of larger stampings that make sense to have a local regional supplier.
But your tooling is a differentiator, right?
It is. So
like you guys make the tooling.
Correct. So the majority of the tooling you see on this rack, we build. A lot of them are 40, 50, some of them 60 years old. So we have hand-drawn prints in our quality department. That tells you how old some of these parts are.
Do people call you and say, hey, I need 10,000 of this widget?
Yeah, so this is, let's see. This is an electrical contact here. So this is a brass part. The way our business model works is our customer calls, or well, sends in an order. Let's say they need 10,000 pieces. We'll pull the die, we'll put it in a press, we'll run the 10,000 pieces, put them in a box and ship them. So, and we may keep inventory, whatever kind of stocking agreement we have with the customer. But,
do you own the die or does the customer own the die?
In most cases, the customer owns the tool. So it's an asset that they pay for up front. We build, and essentially they have the right to come in here and get it and take it anywhere they want to. But if we build the tool, we're familiar with it, they trust us with it, keep it here, run the parts.
So it's a relationship.
It is a relationship, yeah.
That's awesome.
Yeah.
I don't know what this machine is, but I like it.
So that's a dereeler. That's an old dereeler. But you know, they work, and they work like they're supposed to. So.
Oh, I see what's happening. You stretch that in and out. That's awesome.
To kind of push against the idea of the coil.
I'm a simple man, Weston. I see gears, I get excited.
So this is finished goods warehouse.
Yeah, can we see a couple that you're proud of?
Yeah, yeah.
So like if somebody wants to get a part made in Athens, Alabama by some dude named Weston, how do they do that?
So they would send us, the way it works is we receive an engineering print, and that includes material specs, quality, any kind of quality control, let's see, dimensions, everything that's needed to manufacture the part. You send it to us, and then we'll return a quote. So it's really as simple as that. Usage is a big factor as well. So 500 pieces a year versus 5 million pieces a year.
Because your tooling is a huge investment.
Tooling is a huge investment, and material too. We run into minimum material purchases and things like that. So it's important for us to know the usage as well. But and we're not specific to one industry. I've mentioned automotive and appliance a lot, but if you name an industry, we serve it most likely. So, but these are just some of the parts we run. These
are all books about your parts.
So every book you see is a part that we run here. So it contains all of the setup inspection, the
wow. So in theory, a new person that, I'm sorry, I'm cornering you out here.
That's all right.
So, oh wait, that's a huge go, no-go gauge. That's huge. So in theory, a person that hires on here, goes through the tool and die program, they start learning how things work, they should be able, even though they've never run a part, come pick up a book here and then figure out how to set up a press?
Somebody wouldn't hire on in a tool and die program, so they would hire on as a press operator. But in theory, yes, if they came and got a part-specific book, they should be able to pick up where the last operator left off.
Oh, so you bring up people through the press operator program in order to develop their skills?
Correct.
Mm-hmm. That's smart.
Yeah, and Brandon, the guy you met, he was a press operator for several years and moved into the tool and die program. So tool and die is a little more specialized. You don't just hire in as a tool and die maker most of the time. But so a lot of times the operator, when they show a lot of potential, they move up through the pipeline into the tool and die program.
That's awesome. Is this the quality department?
Yeah, this is the quality department.
Can I look back here?
Yeah, sure.
You have CMM? I see you got gauge blocks.
Yep.
Optical comparator. I haven't seen one of those in a while. That's great.
But we actually do have a handheld CMM. So this
is it on? Oh yeah, I see it. Is this the ones that I see what's going on.
Yeah, we just passed the CMM operator on our way in here. Again, they're on brakes.
So this is an optical CMM, and basically it can tell where the hand is, and it can tell where the probe is.
I mean, this is where the operators get the green light to either run parts or stop. What we do what's called a setup inspection. So when we get an order for parts or we put a die back in the press, we'll run a first run sample, and then they're brought here to the quality lab so the quality inspectors can run their processes and tests to make sure the dimensions are met. If they are, they give them the green light and they run the production run. If not, the tool goes back to the tool shop, and they figure out what's wrong with the die. So
That's awesome.
yeah. So this is an example of a customer's assembly. So one of our customers I mentioned is they manufacture a railroad crossing arm. So this is a mechanical relay that is inside of a crossing arm. We manufacture all of the red metal contacts you see in here, and if you look close, there's a little silver part in there. That silver part is almost
That little bitty thing on the top?
that little tiny silver part there. That's almost pure silver.
And you got stamped pure silver here.
Yep, that's right. So the reason for that is this assembly cannot fail in the field. You're talking about lives being at stake if the assembly fails. So that's the reason for the really specific material requirements for this. But
some of the other stuff, is it made as well?
yeah. So the big bracket here, we do that. And this used to be a lot of what we do. These electromechanical relays and contacts and terminals and things like that. But we're getting more into the structural stampings, the larger stampings. As like I mentioned, a lot of this stuff has gone overseas. But the really high risk stampings, they still like to find domestic suppliers, and so that's where we come in. But like I said, we're moving more into the structural larger stampings. So
that's interesting.
Yeah,
I think as the shipping cost goes up overseas, you're going to see some of the smaller stuff come back.
We have started to at least see quote opportunities. None of it has materialized yet, but yeah, seems to be a push to bring things back to the United States.
Onshoring, they call it.
Onshoring, yeah. Whether it be political tensions overseas or labor shortages or material shortages, you're seeing a big push to bring that back to the United States and just reduce that risk that a lot of people are exposing themselves to. But
that's awesome.
Yeah.
Cool. Thank you for showing me all this.
This is the quality department.
How's it going? Hey, I'm Destin. Nice to meet you.
Where is everybody?
Carol. Everybody's gone.
Everybody's gone.
Everybody heard a camera was coming through. Break time. Everybody's eating. Sweet. Stuff's happening.
All right.
All right. So Weston's going to walk us through it one more time now that we know what we're looking at. So can we start over here? Start over here.
Okay. So raw material is and this is the bottom of the die, and this is the top of the die. So
got it.
In the press, this side's essentially upside down. But you have raw material in coil form that comes in this side. Holes are pierced, trims are made, so you have the part in the flat state. And then the forming starts. So you have, there's several of the holes that get formed to keep from the wires, electrical wires being cut and things like that. But the forming starts, and then the final forms are made. And let's see.
Is it upside down?
There we go.
There we go.
Yep. And then you have the part that's, the final form is done, and then it's cut off and falls into
Kicks off, falls down. That's awesome. All right, so here's the tool. That is a single tool, half of it. You helped make it, or somebody did, and you helped make it work. Sheet metal comes along here, chunk, 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 cutting the holes, making the features, and then eventually an entire part falls off. That's amazing. And then it goes to Sharon and she puts nuts on it.
That's right.
Does that part right there, that rivet thing, does that happen inside the tool?
It does happen. Mark can tell you exactly where it happens. I think it's right here.
Here.
Okay.
The cam comes down and drives that forward, and it engages with this piece that's in the top. And it actually pins it right there against.
So it's not a rivet, but it's a. All right. So in this part, let me do this because we learned a lot through the process. Can I stick this back on you?
Sure. I think the technical term for it is a tox.
COX? TOX. All right, so things that happen to this part while it's moving. So it shears it, it punches holes, it rolls things and forms them. That's a hem right there. And then this feature right here, what do you call that feature?
Tox.
T-O-X?
T-O-X Tox lock. And the punch comes in from this side and engages with this shape that's in this upper part. When it reaches final bottom and it's formed the part up, wrap this around, that punch comes in and it hems the two pieces together.
So it's almost like a spot weld, but not.
Right.
It's amazing. I'm never going to look at my lawnmower the same. I'm going to look at all the pieces now and see how they were made.
Yep.
Thank you guys very much. Yeah, appreciate it. Sweet. Yeah. All right, that's it. I can't believe you just watched that whole video. I'm grateful that you did. If you like this sort of thing, feel free to subscribe to this, the second channel, Smarter Every Day 2. I think that would be awesome. And you would probably like the email list if you like this deeper dive content. So if you go to smartereveryday.com, you can click on the link that says email list, and I will send an email every time I upload a new video. And that's a great way to reach out directly, and there's no algorithms in between us. So thank you so much. That's it. I'm Destin. You're getting smarter every day. Have a good one. Bye.